Okay, up to now we've been doing proofs with parallel lines. Today we're going to talk about perpendicular lines. Remember, perpendicular lines are two lines which intersect at right angles. Okay, so here we have a set of perpendicular lines. The perpendicular is also the shortest distance from any point to point on the line. We talked about this when we did reflections and whatnot and finding that perpendicular line. Okay, so it's good to know that the shortest distance is the perpendicular distance. A couple things to be aware of. If two lines form a linear pair of congruent angles, then the lines are perpendicular. So if two lines and we have angle 1 and angle 2. Angle 1 and angle 2 are quite obviously a linear pair, but if we can say that angle 1 is congruent to angle 2, not only are they a linear pair, but they must be perpendicular. They must equal 90 degrees. The only way a linear pair works out that way. If a plane, if a traversal is perpendicular to one of two parallel lines, it is automatically perpendicular to the other. Thinking about what we know about our parallel line converse theorems, this actually becomes pretty obvious. So if we know these two things are parallel, and we know, say, this is a right angle, we know by the rule of corresponding corresponding angles postulate, okay, we know that if these two lines are parallel, then these two angles, angle 1 and angle 2, must be equal, which means angle 2 must also be a right angle or a 90-degree angle, which therefore means that the lines are perpendicular to each other. Okay, so that's the perpendicular transversal theorem. And then finally, if two coplanar lines are perpendicular to the same line, then they are parallel. It's basically this same idea, but instead of using corresponding angles, because the two lines are parallel, you're using the converse. Because these angles are equal, because they're both perpendicular, then the two lines are parallel. So those are the three main things to take away in terms of proofs from this chapter. Okay. There's the bell. Okay, I thought this would be a good opportunity for us to talk about our proofs a little bit and to show you an example of me going through the process of solving a proof, because you guys have had a lot of questions about, how do we do this? How do we move forward on proofs? And sometimes I know it's hard to do that. So I'm going to try to expose my thinking a little bit for you here and just give you an idea of how I approach proofs. So let's start off by looking at this proof. Okay, we're given this picture, and we're asked to prove measure angle 1 equals 135 degrees. And the first thing I'm going to notice about the measure of angle 1 is that it's a linear pair with this other shared angle here. What's weird about this picture is that we have these two parallel lines, but we don't have a transversal going through both of them. We have this sort of angled transversal. So the first thing that occurs to me is I know a lot of rules about transversals. So I'm going to go ahead and actually throw in another line. Right there. Okay. And we're going to say that this line is also parallel to those other two. Why do this? Well, we do this because if this is true, then by our alternate interior angles theorem, this must be equal to those angles, and alternate interior angles theorem, this must also be equal. And if we know that that middle angle is 90 degrees, and these are all equal to each other, then they all must be 45 degrees. And that's going to help me a lot. Because, and here's the whole point. The point of this is I need to get to the point where I can prove number 1. But if I know that number 1, and let's say, and we are going to label another angle here, this number 2 angle here are linear pair, and we know what the linear pair is equal to, we can prove this thing. So let's go ahead and start our proof. we have our statements. And we have our reasons. And the first statement is, I could go through and say all the givens, but let's just assume I do that, okay? The givens. Since they're a picture, it's hard to replicate them in words, okay? And that's given. And then I'm going to draw in this other parallel line. And you don't have to give a reason why you're allowed to do that, okay? You're allowed to draw in extra lines if you want to, if they're helpful. But I'm just going to say that I added line parallel to given lines. Okay, and again, I don't need a reason for that. I'm okay just doing that. All right, now I'm going to say some things about these angles. I'm going to say that angle 1 and 2 are supplementary, and that's because of linear pair theorem, right? And then I'm going to say that, let's label a few other angles here. We're going to call this angle 3. Okay, and we're going to say that angle 2 is congruent. We'll say equal because I don't have a congruent button. Equal to 3, and that's interior, or alternate interior, angles. I can say that angle 3 equals 45 degrees. And we can say that because we know that that line going right through there, we've decided that's a bisector. We've put that in as a bisector. And then we can say that angle 2 equals 45 degrees, and that's just substitution. And then we can say angle 1 plus angle 2 equals 180. That's the definition of supplementary. Angle 1 plus 45 degrees equals 180. That's substitution. And then finally, angle 1 equals 135 degrees, and that's just subtraction property of equality. So let's just go through our logic again. We add a line parallel to the givens, and I should say specifically that it bisects the angle. That's important. Then we go on to say angle 1 and angle 2 are supplementary because they're a linear pair. We go on further to say angle 2 is congruent to angle 3. They're alternate interior angles. Angle 3 is 45 degrees. That's the definition of an angle bisector. Angle 2 is 45 degrees. That's substitution. Angle 1 plus angle 2 is 180 degrees because that's the definition of supplementary. Replacing angle 2 with 45 degrees is substitution, and then subtracting 45 from both sides. Subtraction property of equality. Therefore, angle 1 equals 135 degrees. So that's just kind of my logic. And I really did, in thinking about this proof, I really did start, and I know it didn't seem like it because I kind of still built it from the top, but I started by thinking about this step right here. And that's why, because I knew I wanted angle 1 to be 35 degrees, and I was going to have to figure out, okay, but it needs to be related to other things I know. That's why I started at this step right here. the linear pair step. And so be thinking about that as you do proofs. All right, I hope that guys helps you guys a little bit think about how to build proofs.